or you just don't know what's going on, I would go and watch the videos or go to Khan Academy or something, because the test is Wednesday. So I hope to get through what's half of what's left in the notes today. Monday, I hope to finish it up so that maybe Tuesday we can have time to do review. Review, remember, the test is over 2 units. Test will be Wednesday. Thursday's your EOC. Friday, next Friday will be a video because I won't be here. So that's kind of where we're at right now. All those formulas will be on the board on the day of the test. So no panicking there. And
you talking about those formulas right there?
yes. Formulas will be there. The qualifiers won't. Is it a base, acid, or base, depending on if it's greater than or less than 7. All right, what was the question? Oh, good. All right, so, All right, where do you guys want to start? What's the first thing we know?
POH to find pH.
So we can use POH to find pH. So pH is equal to 14 minus 2.5, which gets me 11.5. Can we determine if it's an acid or a base? So what is it? It's a base. All right, next. How do we solve for OH negative? 10 to the negative POH, which is 10 to the negative 2.5, which is 3.16 times 10 to the negative 3. And the unit is big M, or moles per liter, whichever one you like. How do we find H plus? Do we want to do KW, or you guys want to do 10? 10 to the negative pH, so 10 to the negative 11.5. And when you put that in the calculator, we get 3.16 times 10 to the negative 12. Thank you. So now, go back and check. Do our exponents add up to 15? Yes. Does, if I look at my POH and I round it up to the next whole number, is that equal to the exponent in the OH concentration? Yes. And if I take 11.5 and round that up to 12, does that match what's in my exponent there? Yes. So it is right. So what we're going to talk about today is strong versus weak. And so I need you guys to realize when I talk about a strong acid versus a weak acid, I'm not talking about the pH scale. So if I were to have the pH scale goes from what to what? 0 to 14, with neutral being 7. When I say I have a strong acid, I'm not talking about it's down here. A strong acid could be over here. Strong acid talks about the dissociation. How does it dissociate in water? So if it dissociates 100% in water, it is considered a strong acid or base. So 100% dissociation. So that means if I have hydrochloric acid and it dissociates 100%, then it's going to completely break up into hydrogen ions and chlorine ions. If my molarity of my hydrochloric acid is 0.5 molar, then that means when it broke up, now I have 0.5 molar H ions and I have 0.5 molar chlorine ions.
So it's not strong.
So that makes it strong. That makes it strong because it completely dissociates. I don't have any more HCl's together. Okay?
Oh, so it's kind of like what we did.
It's just like what we did in the last one. So here is our acid. I take my acid, HA, A is generic for acid, so any anion, and I place it into water. When I place it into water, I end up getting all these positive hydrogens and these negative anions. No HAs are left. None of them are left. So this is called 100% dissociation. This happens in strong acids and strong bases. No, I mean it would be a strong acid. What's the definition of a strong acid? Or how do you know a strong acid? Would this conduct electricity? Is there anything there to conduct electricity? What do we need to conduct electricity? We need, I hear somebody saying.
Conductor.
Conductor, no. What are these things called? Oh, electrolytes. But to be but they're what? Positive and negatives. What are positive and negatives called? And ions. Do we have ions? Yes. Ions conduct electricity, right? So this would conduct electricity. And this would, if I had a light bulb, it would be very strong. So this would be a strong electrolyte. So strong acids, strong bases, strong electrolytes.
So say it was like 50% dissociation, but it's still.
It would still conduct electricity, but it wouldn't be the light wouldn't be as bright.
Wait, when would it not?
If it was in some acids and bases, they're going to conduct electricity. It just depends on how strong they conduct electricity, depending on their strength, how much they dissociate. Okay? All right. So 100% dissociation is electrically conductive. Now, a weak acid or a weak base, what happens is we take this acid and we put it into water, and when we put it into water, most of it stays together. We get a couple of them that break apart. So this is what we call partial dissociation. Okay? So partially dissociated. When it partially dissociates, we have some of these positives and negatives here, but everything else stays together. So this is in weak acids and weak bases. So would this conduct electricity?
Yes, but very little.
Yes. So yes, but it would be a weak electrolyte.
So are we going to have to find the percentage of dissociation?
No. An AP, but not here. So weak acids, weak bases, weak electrolytes. Okay? Questions? All right. So how do you know strong versus a weak? Strong bases, strong acids. You have to just either memorize them or do what I do, and instead of memorizing those 7 strong acids, I remember it this way. Everybody remembers I bring clay for our new house? Yes. So I remember I bring clay. So I bring clay are strong acids. And if you have 2 or more oxygens than hydrogens.
Oh.
Okay? So you can either memorize those or know I bring clay and 2 or more oxygens and hydrogens. So hydrogen here, there's 1. Here, 3. Is there 2 or more O's?
Yes.
Here, there's 2. Here, there's 4. 2 or more O's. Yes. If we have H2SO3, I have 2 and I have 3. No. So that would be a weak. Also, any carbon containing acid is weak. So any carbon containing acid is weak. Now the strong bases. Strong bases are those ones that are going to end in hydroxide. They're going to be the group 1A, which is our alkali metals, and our group 2A, which is our alkaline earth, with the exception beryllium and magnesium. The beryllium and magnesium would be weak. So how I think of this is if I have my periodic table, and here is hydrogen. So hydrogen, and then we have beryllium and magnesium. So those are my weak. So I kind of look at it like this. There's my backbone of my B. Those are my strong bases. Okay? So here and here would be my strong bases. Questions on that? Or you could just memorize them. All right.
Those are the only strong bases?
The strong bases would be only strong acids. That's it. Yeah. Okay. So hydrofluoric acid, what they used in Breaking Bad when they melted the body, and hydrofluoric acid is really corrosive. It ate through the bathtub, right? But it's not considered a strong acid based on how it dissociates. It's very corrosive because it's low on the pH scale, but it's not a strong acid.
Did they tested it on Mythbusters and
It didn't work. All right. So concept check. Here I have a strong acid, and when I put a light bulb in it, this lights up really bright. Now, if I take that strong acid out and I replace it with a strong base, would we see any difference in the light? No. If I take the strong base out and now I add a weak acid, would we see a difference? Yes, what would we see? Less light. And what about the weak base? Same thing. Okay, so that's pretty good. What you can just know weak versus strong. But what if I were to say, I gave you a bunch of formulas. H2SO4, is it going to do bright or not?
yes.
Yes, because it's a
Strong.
strong acid. Calcium hydroxide, bright, yes or no? Yes? It's a strong base. Magnesium hydroxide? No, it's a weak base
Wait, how do you know it's a weak thing?
because it has magnesium.
Yeah, okay.
Acetic acid. Any carbon-containing acid is
Strong.
weak.
Oh, weak thing.
So this would be a weak acid. You could do the H's and O's, yeah. I go by the carbons, but you could do the 2 or more O's. All carbon-containing are weak.
Oh, okay.
Okay?
So there's no exceptions to that.
All right, you are expected to be able to do that. I know there's a question on the test. So,
Like which one of these is a weak base?
which one of these would make the light shine brightly? What about salts? Salts are going to shine brightly no matter what. Okay, so salts are going to shine brightly, and then your strong acids and your strong bases.
So what if there's like a strong acid and a strong base? So can I ask like
Even
which
stronger.
Then you would say, Miss White, there's something wrong with the test.
Okay, so I can't.
Okay.
So one of the answers would only be base A or
Or a salt. It might be a salt. All right, because if I said, Would this, if I had NaCl, it would be an electrolyte, a strong electrolyte. Okay? All right, now calculations. This is just like we've been doing. We've been doing calculations, except for now we're going to talk about with acids and base, the strong acids and the strong bases. So what you have to do is the following. Take your formula. Nitric acid. What is the formula for nitric acid? HNO3. What's it going to break into? What are the ions of it? H plus and NO3 minus. Is it balanced? Yes? We don't have to do anything to balance it. So this is where writing this is going to help you in the long run. Because now I tell you that you have a solution of nitric acid that's 0.033 molar. So that means this is 0.033 molar. pH is based off of what? This, or this? The H. So I need to find what the pH is based on this. Is HNO3 a strong acid? 2 or more O's and H's. Yes. So then when this breaks up, what's the molarity of this? 0.033. What's the molarity of this? 0.033. Now can we calculate the pH of the solution?
Yes.
Yes. So pH is going to be equal to the negative log of 0.033. Put that in the calculator. Get it for me.
That's log, not 10.
Yeah, somebody said, what's that 10G? What? 1 point what?
4, 8.
Wait, what's that at?
1.48.
Negative log. Hit the negative
So
and then
hit negative and then log right here. 1.48. It's nitric acid. So that means my pH better be less than 7. Is my pH less than 7? Yes, we're good. 1.48. Mm-hmm. All right, next. We'll do one more, but this time I'm going to change it up a bit. Instead of doing hydrobromic acid, we're going to do hydrosulfuric acid. Okay. Hydrosulfuric acid is H2S. And this one doesn't work out either. No, let's do sulfuric acid. H2SO4. And when it breaks down into its ions, what's it going to break into? H plus and SO4 2 minus. Is it balanced? No. I need to put a 2 there. The pH is 3.2. So which one of these gave me the pH? The H plus. So pH is 3.2. So knowing pH, I can find my hydrogen ion concentration. So to find hydrogen ion concentration, 10 to the negative 3.2. Put that in the calculator. What do we get?
6.3.
4 molarity. Everybody up to there? Good? What is the initial, so that's the hydrogen ion concentration. What's the initial concentration of this solution? 3.2. What is the initial concentration? So, for every one of these, how many of these do we get? 2. So what do I need to do with this concentration here? Times it or divide? Divide it by 2. So we're going to divide it by 2. And we get what? What?
3.15 times 10 to the negative 4.
Negative 4. And that is the concentration of my H2SO4 solution.
It was 3.15.
Oh, 1.5. Ooh, there we go. Okay, so you've got to look at these coefficients in front, too, when we're talking about strong acids, strong bases. So everybody understands why we divided it by 2. Okay, so this is for the all of this H+, right? But the ratio, if we look at the stoichiometry, for every one of these, we get 2 of these. So this is for 2 H+, but we only have 1 H2SO4. So we have to divide this by 2 to get the concentration of H2SO4. How do you put that in what? 6.3 e to the negative 4? All right. Now what happens when it comes to bases? Bases are a little bit different. It's a little bit more math. So here we're going to go with sodium hydroxide. And it's going to break up into what 2 things? Na and OH. The concentration of sodium hydroxide is 0.0667. It's a strong base. So what's the concentration of my Na and my OH? 0.0667. All right, so what do we want to do with this concentration? It's my hydroxide concentration. So what can we find with my hydroxide concentration? We can find POH. So put that in the calculator, get me the negative log of that. $1.18? 1.18. Are we done? What's wrong with it? It's asking for the pH. Half of you guys are going to stop right there.
So you have to do 14 minus
4. 12.82. Okay. So, and when you do this, look and say, does it make sense? If we were to say that this was pH of 1.18, but it's a sodium hydroxide solution, does that make sense? No. The pH needs to be greater than 7. So that will be where you make your mistakes. We're going to do one more, and then I'm passing back your quizzes, and then you can do your corrections. Okay. This time we're going to talk about barium hydroxide, or calcium hydroxide. So calcium hydroxide breaks into calcium 2 plus and OH minus, but we need 2 OHs. Concentration of calcium hydroxide is 0.033. What's the concentration of Ca, since this is a strong base? When it breaks up, it's going to 0.033. OH is going to be what? 0.063. Yeah, 2 times 0.033. So 0.066 is our concentration. So now what can we do? Find POH is going to be the negative log of that, which is 1.18 again?
Yes.
1.18. And now we have to find pH. 14 minus 1.18 is equal to, can somebody grab that for me? 12.82. And we're done. Questions? The thing is I would do this so that you know you're under the OH, and that's what you're dealing with. Okay?
So you put the .066 into the POH?
Yes. All right. That is it. I'm going to